This lesson is on section 12.4. It includes the angle measures inside, outside, and on a circle, and segment lengths inside, outside, and on the circle. There's one definition word for today. It's called the word secant. The secant is a line that goes through the circle and intersects it in 2 points. So this is an example of a secant line. It intersects the circle in exactly 2 points. This one's also a secant line. It intersects the circle in 2 points. It's kind of like a chord. A chord is a segment that intersects it in 2 points. The secant just continues on in both directions, making it a line. So the first 3 topics that we're going to talk about have to do with angles that are created inside the circle. That have angles that have something to do with being on the circle. For example, this first one has to do with the vertex. Okay? In the case where the vertex of the angle is on the circle. Okay? So the corner of your angle is on the circle itself. The relationship is that the measure of the angle is exactly half of the measure of its intercepted arc. So what that looks like, for example, this angle is angle X. Its intercepted arc is the one that sits between the 2 secants. So half of 60 would be 30. This measure would be 30 degrees. This one, we can see that the angle is 140, and using this relationship, we can then find the measure of the intercepted arc. The intercepted arc goes between the 2 chords, so it's this entire arc here, and the relationship is that the angle is half of the arc. So since 140 would be half, the arc itself would have to equal 280 degrees. The second kind of angle that we're going to work with is when the vertex of the angle is in the circle. So in other words, that corner point is on the interior of the circle. The relationship for that is that the measure of the angle is the average of the 2 intercepted arcs. So if I was looking for, you can see the X, but it's very small there. If I was looking for this angle measure, I would take this intercepted arc on this side and the one on the opposite side, because it creates 2 intercepted arcs, those secants do. And I would add those together and divide by 2, because that's finding the average. So I would add 60 and 100 and get 160 and divide it by 2, and X would be equal to 80 degrees. The third kind of angle that we're going to look at is when the vertex of the angle is outside of the circle. Okay? So notice our relationship on, it was half. In, it was the average. Outside, the relationship is that it's half of the difference. When it's inside, it's half of the sum. When it's outside, it's half of the difference. So in this case, when the vertex is outside of the circle, we are going to take half of the difference. So we're going to subtract our 2 arcs and then take half of that. Okay? So this one goes like this. You'd take 270 and you'd minus 90, which gives us 180. And then you would divide that in 2, and half of 180 is 90. So our X angle here would be 90 degrees. We'd take 270 minus 90, which is 180, and then we'd divide that by 2. We'd take half of it. Okay? Sometimes you'll get the angle measure but not the arcs, and you're still going to use the same formula, but you're going to have to use it backwards a little bit. Okay? So this one, the angle is 50, and the bigger arc is 110, but we don't know what the smaller arc is. But I know if I take 110 and I minus X and then divide that by 2, I have to get my angle measure. And my angle measure is 50. So big angle or big arc minus little arc divided by 2, half of that, would be equal to the angle measure. So that means when I subtract my arcs, I should get 100 because 2 times 50 is 100. So when I take 110 minus x, I should get 100 so that when I divide it by 2, I get 50. So 110 minus x has to equal 100, which means then that x has to be 10 degrees. 110 minus 100 is 10. The last example problem here is when it's the outer arc that is missing, and you know that the angle measure and the inner arc. So you would know that when you take x minus 5 and divide it by 2, you should get 25. That's how that goes. Outer arc minus inner arc divided by 2 gives you your angle, which means that x minus 5 has to equal 50, because 2 times 25 is 50, doing our algebra. And so therefore x has to equal 55. So the outer arc would have to equal 55 degrees. Okay. So on the circle, if the vertex is on the circle, it's half of the arc. If it's inside the circle, you have to add your arcs and divide by 2. And if it's outside the circle, you have to subtract your arcs and divide by 2. The other three things we're going to talk about today are the segments themselves. When we use secants or even chords or even tangents, there's a relationship among the lengths of the segments themselves. So the first one is when the segments are inside the circle. The relationship is the product of the two lengths of one equals the product of the two lengths of the other. So in other words, A times B, my length A times my length B, has to be equal to my length C times my length D. The next one is when you have secants but they intersect outside the circle. Okay, they intersect outside the circle. This one's a little bit trickier. In this case, the relationship is the whole piece, so x plus w, times just the outside. So x plus w times times w, equals y plus z times y. So the total times the outside equals the total times the outside. And that's what I have written here. The last one is if one segment is tangent to the other. So we have one secant that intersects the circle in two places, and we have one tangent. If you remember, the tangent hits the circle in exactly one place. So if you would have the secant and a tangent, then there's still a relationship. The relationship involves the total times the outside, but this one doesn't have a total, it just has the outside. So the total times the outside equals the outside squared in the case of a secant and a tangent line. And we're going to do example problems of those just coming up in a few seconds. Okay, but if the lines are inside the circle, you times them, times the two halves, and it has to be equal to timesing of the other halves. When there's two they intersect outside the circle, you take the total times the outside equals the total times the outside. And when you have a tangent, you have to square the tangent because that's the only value you have. So tangent squared equals the whole thing times the outside. So let's look at some example problems of those. All 6 of the topics we just talked about. Okay, the first one. Here we're looking for an angle measure, and our vertex is outside the circle. Okay, since the vertex is outside the circle, the angle is half of the difference between the arcs. So we're going to take half of 64 minus 20. 64 minus 20 is 44. Half of that would be 22, and that would have to be the value of x. Okay. We learned that y times y equals 50 times this piece. We don't know what this piece is, but they do tell us that the radius of the circle is 125. Well, if the radius is 125, then how long does the diameter have to be? Well, the diameter has to be 250. So then the bottom vertical part, if the top is 50, the bottom vertical part would have to be 200. So this piece here is 200. So now we're going to take y times y equals 50 times 200, which gives us y squared equaling 10,000. And then to solve, we square root both sides, and y is 100. Okay. In the next one, we have an x and a y to solve for. Let's start with x. X is a segment, and it's intersecting the other segment inside the circle. So that means we're going to do the pieces times the pieces, just like we did in the last one. So 3 times 14 equals x times 10. So 42 would equal 10x, or x would equal 4.2. To find y is an angle measure, and its vertex is inside the circle. So since it's inside the circle, we are going to add our arcs and divide by 2. So take half of 30 and 85, which gives us 57.5. Here we have a tangent and a secant. So we're going to square our tangent because that's the only value we have. And then we're going to set it equal to the total times just the outside. So the total would be 20, or 12 plus 8, times 8, and that would be equal to x squared. 20 times 8 is 160, so x squared equals 160, which leaves x, when you take the square root, to be 12.6. This last one involves two secants, and they're intersecting outside the circle. Since they're intersecting outside the circle, it's just the total times the outside equals the total times the outside. So the total for the first one would be 20 plus 15, which is 35 times 20, which is the outside. And then the other way would be 25 plus x would be the total, times 25 would be the outside. From here, it's just an algebra problem. 20 plus 15 is 35. 35 times 20 is 700. I have to distribute the 25 here because 25 and x can't go together. So 25 times 25 is 625. 25 times x is 25x. I'll then subtract my 625 over to the other side. So 700 minus 625 is 75 equals 25x. And then I would divide by 25 and x would be 3. Okay? Those are examples of the kinds of problems you're going to see today in your homework. Your homework for each of your classes is the following.